Adding and subtracting go together. Multiplying and dividing go together. Adding fractions and subtracting fractions have very similar rules. I explained why this is the case in the previous set of videos called Adding and Subtracting Fractions, and hopefully the link to that previous set of videos is in the description of this video. So one may think that multiplying fractions and dividing fractions have similar rules. Because of this, and because to multiply fractions you multiply both the numerators and denominators, now I explain why that's the case in the previous set of videos called Multiplying Fractions, hopefully linked in the description of this video. But anyway, because of that, the conclusion may be to divide fractions, you divide both the numerators and denominators. This is the conclusion that I came across when I was in 5th grade math, and we hadn't learned about keep, change, and flip quite yet. This is actually true, but it's less efficient, and it is slower than keep, change, and flip. First, let's show in 2 different ways why dividing both the numerators and denominators works. Now, the second way is a lot quicker than the first way, but different people understand concepts in different ways. Then let's use this method of dividing both the numerators and denominators to explain keep, change, and flip also works to divide fractions. 4/9 divided by 3/5. Based on the information in the previous video and the set of videos about why the fraction bar means divide, we can know that this is equal to 4/9 over 3/5. Now anything times 1 is equal to that anything, so 4/9 times 1 is equal to 4/9. Based on the information in the previous set of videos about multiplying fractions, hopefully linked in the description of this video, we can know that 3/5 is equal to 3 times 1/5. Now based on the commutative property of multiplication, hopefully linked in the description of this video, we can know that 3 times 1/5 is equal to 1/5 times 3. Now to multiply fractions, you multiply both the numerators and denominators, so let's kind of undo the multiplying of the fractions, and we get 4/9 over 1/5 times 1/3. Now based on the information in the previous set of videos about 12 divided by smaller numbers, hopefully linked in the description of this video, we can know that 4/9 divided by 1/5 is equal to 4/9 times 5. Now 4/9 is equal to 4 times 1/9 based on the information in the previous set of videos about multiplying fractions. Now multiplying does not matter, to multiply numbers it does not matter in which order you multiply them. This is based on the commutative property of multiplication and the associative property of multiplication, both hopefully linked in the description of this video. So let's reorder the multiplying. This does not change the answer. This does not change the product. And so we have 4 times 1/3. That would be 4/3 based on the information in the previous set of videos about multiplying fractions. And based on the previous video and this set of videos about why the fraction bar means divide, that would be 4 divided by 3. Now anything over 1 is equal to that anything, so 4 divided by 3 over 1 is equal to 4 divided by 3. Now we're multiplying 2 fractions. So let's multiply both the numerators and denominators, and that would be 4 divided by 3 times 1, or 4 divided by 3, and the denominator would be 1 times 9, or 9. Now based on the information in the previous set of videos about 12 divided by smaller numbers, we can know that 5 is equal to 1 divided by 1/5. Now we're multiplying 2 fractions. So let's multiply both the numerators and denominators. And so we have for the numerator 4 divided by 3, and that times 1. And for denominator we have 9 times 1/5. Now anything times 1 is equal to that anything, so 4 divided by 3, and that times 1 is equal to 4 divided by 3. Now 9 times 1/5, that is equal to 9/5 based on the information in the previous set of videos about multiplying fractions, and based on the previous video and this set of videos about why the fraction bar means divide, that is equal to 9 divided by 5. So we find out that 4/9 divided by 3/5 is equal to 4 divided by 3 over 9 divided by 5. Therefore, one way to divide fractions is to divide both the numerators and the denominators. We could have used the information in the previous slide, but used variables instead to show that this idea of dividing fractions by dividing both the numerators and denominators works for whatever fractions you may come across. I would now like to use a lot quicker way to explain why this idea of dividing both the numerators and denominators, why that works. 3/8 times 5/7 is equal to 3 times 5 over 8 times 7, Because to multiply two fractions, we multiply both the numerators and denominators, and I explained why that is the case in a previous set of videos about multiplying fractions, hopefully link in the description of this video. Now let's divide 5/7 on both sides. Now we have 3/8 is equal to 3 times 5 over 8 times 7 divided by 5/7. Now let's flip the two. So let's have the old left side being the new right side and the old right side being the new left side. Basically, if A is equal to B, then B is equal to A. And so, how would we have gotten directly from 3 times 5 over 8 times 7 divided by 5/7 is equal to 3/8? How have we gone directly from there to there without taking these intermediate steps? Well, we would have divided both the numerators and denominators. 3 times 5, and that divided by 5, is equal to 3. 8 times 7, and that divided by 7, is equal to 8. So what we're doing is we're dividing both the numerators and denominators to divide these two fractions. So this idea of dividing both the numerators and denominators, that works. We could have used the same pattern in the previous slide, but used variables instead to show this idea of dividing both the numerators and denominators works for whatever case you may come across. Let's now use this knowledge of dividing both the numerators and denominators to help us understand why keep, change, and flip works. 4/9 divided by 3/5. We can multiply 3 to both the numerator and denominator of 4/9 to expand this fraction. Now in the previous set of videos about simplifying and expanding fractions, hopefully linked in the description of this video, I explained why that is the case. Now I could have simplified 4 times 3 to 12 and 9 times 3 to 27, but I decided to keep it as so that hopefully we can later see the pattern. Now let's multiply both the numerator and denominator by 5. To divide fractions, one way of going about that is dividing both the numerators and denominators. Now 4 times 3 times 5, and that divided by 3 would be just 4 times 5. 9 times 3 times 5, and that divided by 5, that would be just 9 times 3. And so we have 4 times 5 or 9 times 3. Now to multiply two fractions, you multiply both the numerators and denominators. Now I explained that as the case in the previous set of videos about multiplying fractions, hopefully link in the description of this video. So let's undo the multiplying of these fractions, and we get 4/9 times 5/3. And so we find out that 4/9 divided by 3/5 is equal to 4/9 keep times change 5/3 flip. We keep the 4/9, we change the divide sign to the times sign, and we flip the 3/5 with 3 the numerator and 5 the denominator to 5/3 with 5 the numerator and 3 the denominator. We could have used the pattern in the previous slides, but used variables instead to show this idea of keep, change, and flip works for whatever case you may come across. Thank you for watching this video. I would appreciate it if you would subscribe, like, and comment. Here's a link to the playlist in which this video is a part of. Feel free to click on this link.